Hello, my name is Harley Fuller, and this is my Lab 3 video report. For the agenda today, I will be discussing the problem that we have successfully modeled, showing some of the experiment performed and its results, going through calculations that help explain the reason behind our experimental results, and how we can code a model on computer programming. To introduce this experiment, I will go over the basic goals, materials, and procedure that was used. Our goal is to explore the fundamental physics principle of magnetic forces and fields on objects. We are collecting magnetic field readings at various locations near a magnet. We will be utilizing a smartphone to get the data points for this experiment. The materials used in this experiment consist of a magnet, a ruler, and a smartphone with a magnetometer app. To begin, I aligned my phone to be parallel to Earth's magnetic field. This helps limit the free variables in our data so that we have less unknowns to deal with. I then placed a ruler down under my phone to use for measuring distance. I then placed a magnet to the left of the phone, which is what is creating the field we are measuring. I used the given website to test if the magnetic field due to Earth at my location was equal to the one that my phone was reading. Once the preparation was finished, I moved on to experimenting, which I will show you on the next slide. In the lab document, we were asked to find various magnetic forces and log the distance and force in the x direction. This allows us to collect many different data points and ensure we get an accurate trend. Upon entering data into the provided spreadsheet, it fills out a trend line. For the second part of this experiment, we placed our phone at a 45-degree angle and a length d away from the magnet. This helps us find values to compare to our coded model, which ensures we are computing accurate data. Some calculations were required to get specific values and will be shown on the next slide. The values we need for our code are n and k. The trend line from earlier has a slope, which tells us our n value. The intercept is equal to the natural log of k. These values help us find the magnetic dipole moment, which we are also calculating in our coded model. Our calculated magnetic dipole moment should be similar, if not equal to our computer calculated model. On to the last part of our agenda, I would like to discuss the coding aspect of this lab. The code takes the value of mu and the distance to calculate the magnetic field of the magnet. We then create arrows to show its magnitude and direction. This is an accurate way to show the force exerted on the phone by the magnet without involving the force of Earth's magnetic field like our experiment. In conclusion, I would like to answer some questions. What if you hadn't oriented your experiment to compensate for magnetic north and had instead laid out your meter stick at some intermediate angle with respect to Earth's magnetic field? How would your results have changed? If I hadn't compensated for magnetic north, my values would be off by the magnitude of the magnetic force of the Earth. This could really throw off data and give false results, which is why the setup of this experiment was so vital. The second question asks, if you were to stick two identical magnets together end to end and run the experiment again, how would you expect your measurements to differ? Well, if I were to stick two magnets end to end, the magnetic force would increase. They simply act as if they were one larger magnet having a greater magnetic field. Through this lab, we took common household objects and experimented with the physics principle of magnetic force. We discovered our values of n and k, which subsequently gave us our magnetic dipole moment. This lab also helped us visualize separate hypothetical magnetic forces through computer programming. All in all, this concludes my Lab 3 video report. Thank you for watching.